In this video, we're going to talk about how a dry cell works. So, a dry cell is actually a battery which we use every day. And this is how a dry cell looks like on the inside. And these are the components of a dry cell. It's called a dry cell because there are no liquid component inside it. And that is why it's so durable. So, the container of a dry cell is made up of zinc, and this zinc container acts as the anode. There is a metallic cap at the top and a seal or a washer just behind it here. And in the inside of this cell, here is manganese dioxide, ammonium chloride, and zinc chloride. And at the middle, here's a carbon rod, and this works as cathode. The carbon rod works as the cathode, and this becomes the negative terminal of the battery, and this is the positive terminal. So now let's see what reactions takes place here first. So these are the reactions that are going to take place here. So first, let's say the reaction at anode, which is always oxidation. So, what happens at the anode? Zinc at the anode will donate an electron and join the cell as a zinc cation. So let's write it down. Here, zinc will donate 2 electrons actually, and will become zinc cation and will join the cell. So this is the reaction at the anode. And now let's look at the reaction at the cathode or the carbon rod. So here is the reaction at cathode, which is reduction always. So actually there are 2 reactions taking place in this cathode. The first one is with ammonium here. So ammonium gains 2 electrons and becomes NH3, and it produces hydrogen gas. This is the first reaction which occurs at the cathode. And now this hydrogen gas will react with zinc. Not zinc actually. It will react with, sorry about this, hydrogen gas will react with manganese dioxide. Now here hydrogen gas reacts with manganese dioxide and produces Mn2O3 and a water molecule. So these are the 2 reduction reactions which are taking place in the cathode. But wait, we need just 1 reaction. What is the total reaction that is occurring in the cathode? To find the total reaction, we just need to add these 2 up. So hydrogen on the both sides cancels out. So we cancelled out the hydrogens. and here is only remaining the ammonium and the, okay, here should be 2, right? 2 manganese dioxide and 2 electrons, which are resulting in 2 NH3 plus Mn2O3 and water. Ooh, it is a big reaction. So, this is the reaction which is taking place at the cathode. Now, how do you find the total reactions which are taking place in this whole cell? To find this, you need to add the oxidation and reduction reaction. So we have to add this and this to find the total reactions in this solution or cell. Now, here is zinc and 2 electrons is deducted here. So we can just cancel out these 2 electrons, right? Because they're on the same side of the reaction. So let's write them down. First, there is zinc. So zinc plus ammonium, 2NH4 plus. Here is manganese dioxide. So we're going to add this now. MnO2, right? And the electrons cancel out, so we don't need to write them down now. Which are resulting in. So first let's look at what's the result of the oxidation. So the zinc ion, we're going to write it first. So here is zinc ion, and so yeah, here it is, zinc ion and 2 NH3 here, and from here Mn2O3 and water molecule. So this is the overall total reactions which is taking place in this cell or tricell. This is the reaction. So now, how does the tricell work actually? After the reaction, okay, let me rub this up first. We don't need you now. Get out of here. So, and let's rub this up as well. So these 2 terminals are connected by a wire, and there is a light bulb. And after the reactions takes place, electrons flow through this wire, and thus the light bulb works. See you in the next video.